Today we shall have stepper motor interfacing with 8051. All in all, the stepper motor is the one which converts electrical pulses into a mechanical movement. Means just like a DC motor, stepper motor also rotates. But the stepper motor rotates in a steps. It will have teeths, and teeth by teeth it rotates. That we call it as a stepper motor. Now how to interface this stepper motor to microcontroller and run this stepper motor, we shall see. Okay. Here, all in all, the stepper motor will have one permanent magnet called as rotor. This is also called as shaft because it is internally connected to the shaft which is coming out of the stepper motor, right? So rotor, the permanent magnet. Apart from that, it is surrounded by temporary magnets which are called as stators. Here in this particular example, we have 4 stators. The rotor is surrounded by 4 stators. It could be surrounded by 8 stators also. So multiple stators will be there, and these stators are temporary magnets. Means to say that these are the coils. When these coils are energized, the magnetic induction takes place and these coils starts acting like a magnets, right? So these are called as stators. You can see that the sequence A, stator D, stator B and stator C. We have 4 stators, and these stators are responsible for the permanent magnet to rotate inside. What happens actually is, this will be the north pole of all the stators, and this shall be the north pole of rotor. When this particular stator and this particular stator are energized, when stator A and stator D, they are energized, north pole and north pole repel this particular north pole. Therefore, the rotor will come and stand like this. Immediately after energizing A and D, you will have to immediately energize D and B, so that this rotor will now come and stand like this. When you are energizing D and B, you should ensure that C and A are de-energized. Similarly, after you energize D and B, you energize B and C, so that the rotor will now turn and stand on this side between these two. And again, when you energize next C and A, the rotor will stand like this. Like this, you will make the permanent magnet rotor to rotate under the influence of stator. If you are making AD, if you are energizing AD, then DB, then BC, then CA, you are making the rotor to rotate in clockwise direction. If you would want the rotor to be rotated in anti-clockwise direction, if you would want the stepper motor to be rotated in anti-clockwise direction, in that case you will have to first energize AD, then AC, then CB, BD and DA. So this is the constituent of stepper motor. Okay, we shall look into the interface that we have with 8051. This is 8051, and how we can interface that 8051 with stepper motor. This is a logical representation of stepper motor, right? And you can see that there is here one of the coil. This you can call it to be A, and there is another coil coming here. This coil you can call it to be D, and there is one more coil which is coming here. These are stators, temporary magnets. You can call it to be B, and there is one more coil coming here. You can call it to be C. So in total, you have 4 stators which are connected to 8051. Means to say that through the values that we send from 8051, we are energizing or de-energizing these 4 stators, ABCD stators, right? And in this particular interface, you can see that it is the port 1, P1.7, P1.6, P1.5 and P1.4. 4 bits of port 1 is actually interfaced, is actually connected to send the data directly to stators A, B, C, D, right? But you will have to keep one thing in mind. When you send logic high, it is going to be plus 5 volts. And when you send logic low, it is going to be 0 volts, right? But this particular stators gets energized at plus 12 volts. Therefore, plus 5 volts will not be able to energize the stators, and because of that you have here the driver circuit. There is something called as ULN2003, which is a driver circuit which converts 5 volts into 12 volts. The input coming to ULN2003, if it is 5 volts, the output shall be 12 volts. Thereby you make this higher pulse 12 volts so that it can energize any of the stators, right? So this is the interface diagram, and whenever you would want to energize and de-energize the stators, accordingly you will have to send the values through port 1, P1.7, P1.6, P1.5 and P1.4. Now, how do you send the values? To send the values, you can see here, port P1.7, port P1.6, port P1.5, port P1.4. Now, initially what I'll give is value 0, 1, 1, 0. This means that P1.7 is actually connected to A. This is connected to D. And the third one, it is connected to B, and this is connected to C. So you are energizing D and B here. If you come back and see in the diagram, D and B, it makes the rotor stand here. Fine. After this, immediately you will have to energize B and C. B and C. You will have to energize B and C. So that now the rotor will come and stand here. Okay. So in the next sequence, what you will say? You will have to energize C and A. You can see here, A is energized and C is energized, right? So in the next sequence, so it will come and stand here now, right? Next we will have to energize A and D. So if you have to energize A and D, it is A equals 1 and D equals 1. You are energizing this. So this is the sequence in which if you keep on giving the values to stepper motor, the stepper motor starts rotating in clockwise direction. The same sequence if you give from the bottom side, first you give this value, next this, next this, next this. If you go in this direction, the stepper motor will rotate in anti-clockwise direction, right? Thank you.